While loops are other means of iterating over the same block of code. It is similar to the if condition. As you would recall, the if condition would execute the inner code if the condition was true. But it would do this only once. While loop, on the other hand, executes this internal block as long as this condition evaluates to true. So it just makes a comparison, makes a check whether this condition is true, executes this inner part. After the block is complete, it goes back and rechecks the condition. It does this check each time it completes an iteration. It completes an loop iteration. And if this condition again evaluates to true, it's going to repeat the intersection once again, and this goes on until this condition evaluates to false. If it is false, it's not going to execute any further and continue with the next statement following the while loop definition. The break and continue statements apply to while loops as well. You can also have nested while loops inside for loops inside while loops. There's no such restriction. Anything can be placed, any valid, legitimate code can be inserted inside the while loops body. The trick is that the loop makes a conditional check each time it's going to attempt to execute the inner code. So if this condition, let's say this is a function call, is while valid, let's say. So if we had a function like that, and it would be returning either true or false depending on the constraints in the current execution. At some point, this function might return true or false. If it returns true, it's going to execute this while loop. If it returns false, it's just going to stop executing any further. Or it might be a numerical check. Let's say you have a variable x is 10. You check whether while x is less than 20, you do something, and at some point you increment your x by 1. So it's going to go back. X now contains 11. 11 is less than 20. It makes this conditional check each time it's going to attempt to execute the while loop. Okay. So we have an example here with the while loop. So what it does is it checks whether the current x coordinate of our turtle is between minus 350 and plus 350. Also, at the same time, it checks whether the current y coordinate of our turtle is also between some values. They don't have to be equal. You might specify other values. If so, if the turtle is inside this box, let's say there's a box, it's going to draw some random shapes. Okay, it's just going to pick a shape. If it's 0, it's going to draw a square. If it's 1, it's going to draw a triangle, circle, etc. And whenever it completes the shape, it might end up outside the initial viewport, initial boundaries that we have specified. This might be minus 350, 350. Also, I think it goes like this, minus 350, 350 as y, x and y values. So if our turtle ends up outside the boundary, the while loop, this while loop is going to evaluate to false, and it's not going to execute any further. Let me see. Okay, we have turtle done at the end of the while loop, so we could have some print statements before we complete. Okay, it would simply terminate the while loop and continue with the next statement. So let's run this code first. So it's generating random shapes of random size. As long as the turtle's coordinates stay inside the given boundaries, it keeps on drawing. At this point, turtle has moved to a location which is outside our specified boundary, so it stopped drawing. There's this well-known number guessing game. The algorithm for this game is that the computer generates a secret number. It doesn't tell us which number it has picked. The number is between 1 and 100, and it receives a guess from the user. If the guess is less than the secret number, it's going to output your guess is too low. Otherwise, if it's more than the secret number, if I have guessed, I've provided an input more than the number picked by the computer, it's going to output your guess is too high. Otherwise, which means the guess is not less than or greater than the secret number, it has to be equal to the number picked by the computer, and it's going to end the execution. So but this keeps on running as long as I have not guessed correctly. So let's run this and execute our code. So let's say I'm entering the value 4. It says your guess is too low. If I keep on entering 4 for infinitely many times, this loop is never going to end. Okay, I'm just entering 4. So if I enter 5, it's still too low. I have entered a space, so that's not a number, and an exception occurred because of that. That's not important, but looking at the internal part of our code, we have this inner while loop which executes forever. Okay, while true means there's nothing that can stop this loop from repeating the internal code unless we have a break statement. Okay, continue, as you would recall, goes back to the condition check and continues from there, ignoring the remaining part, or discontinue similarly ignores the remaining part. But break is going to terminate your while loop, which is the inner while loop here. So break is going to terminate the first while loop encapsulating itself. It's not going to terminate this outer while loop, which I'm going to discuss soon. So it first receives a guess from the user. If guess is less than the number initially picked by the computer, which it doesn't tell us, okay, it doesn't tell us there's no print n, so we don't know what's inside the computer's mind. If my guess is not less than n, or if it's greater than n, it says your guess is too high. Otherwise, my guess has to be equal to the number picked by the computer, and it terminates the loop. Okay, it stops receiving input from the user using the break statement, and it's going to continue with the next statement. So if I didn't get this error in the first place, let's say I enter 30, it says my guess is too low, and I enter 60, and I double clicked the enter. Sorry for that. Let's start from the beginning. Too low. I'll be more careful now. It's too high. I know that my number is between 30 and 60, okay? So I should try something like 50. It's too low. I know that my number is now between 50 and 60, so I try 55. It's too low. My number is greater than 55. Okay, the number was 57. And the computer tells me my guess is correct. So this inner loop is complete. Okay, this part is complete. Now the computer asks me whether I want to continue with another round of guessing. If I enter something starting with N, no, nope, nay, okay? If I enter something that starts with an N or a small n, so it just converts my choice to lowercase and checks whether it starts with a small n. It's going to convert this running parameter to false. It's going to convert this to false, and this outer while loop is complete. So setting this running variable to false means that this iteration of the outer while loop is complete. It's going to check whether running is true or not. If I enter something starting with n, it's going to see that running is set to false, which was initially set to true before executing the while loop itself. It's going to check this condition, running is false, so it's not going to execute it, and it's going to tell me goodbye. Let me enter n here as the input. Let's run this once again. So I'm going to enter 50 without the comma. I'm going to enter 50. Too low 75. Too low 85. Too high 80. Okay, now I enter n carefully and press return, and it tells me goodbye. Okay, so I terminated my loop either by using a break statement or setting a value to the condition it is checking. so that it's going to evaluate the false. So this is going to terminate this loop. This could just as well have been a function check. So I would be checking whether a certain condition is still evaluating to true. It might depend on the time of the day. You might not want your program to be executed after 7 p.m. or you might want to display some different messages depending on the time of the day or day of the week, etc. So these condition checks might be numerical checks, some variables as you see here, some functions, some compound conditional checks, anything, any Boolean expression is valid and it's going to be evaluated before the while loop is going to attempt to execute its inner contents. So let's run this with a repetition. So if I don't enter anything starting with n, still too low, 90, 85, 87, 88, 89 then. So if I enter yep, or in this case evet in Turkish, it would still be checking whether my input starts with n. So it's not starting with n. It's going to generate this number. It's going to generate this next number. Let's execute this once more. So enter 50. Couldn't just catch the too low. It couldn't catch the mouse click. Your guess is too high, so it should be something around 33. Too high. 32. 32, and I say yes, or evet in the earlier case. Okay, now I'm in my console, so it generates the number once again and asks me. So it jumped as I didn't enter something starting with n. This is not executed, so my running variable is still true. As this is not executed, it's going back to the outer while loop, checking whether running is true. It is. I haven't modified it. It generated some number and asks me to enter a number between 1 and 100. So I again start with 50 and it says it's too high, it's too low, 35, 30. Okay, now I can continue this process forever. There's nothing that can stop me from doing that. But if I choose to terminate my program, I simply enter nope, and it tells me goodbye. So I have terminated both loops, both the inner one and the outer loop, simply by entering n. So what are the strategies of guessing these numbers? This is slightly related to algorithm complexity. There is this best case and worst case analysis of algorithms. So if I start guessing the lowest number and increment by 1, so the lowest number is 1. Okay, I start with 1. If I start with 1, in best case, the computer might have already picked the number 1. Okay, and I would be guessing this number at a single iteration. At worst case, the computer might have picked 100, and if I start with the smallest number, I would have to increment 100 times. So this is the worst case analysis, that I would have to provide 100 numbers to find this. Starting to guess from the highest number is similar. The computer might have picked 100, and I would start from 100 to guess the number and decrement by 1. At one iteration, I would find this. If the computer picks 1, and if I start again with 100 and decrement to 99, 98, I would have to do this for 100 times. Just 100 times. Okay. So in worst case, it would, both strategies, starting with smallest and the largest number, are equal in the worst case and best case. Always pick a random position, random number. So let's say the computer generated 1, and I'm asking the random library to give me a random number for guessing, or I might be doing it myself, just tossing some dice or some other code to give me a number. So I would be guessing 33, and if I don't repeat my earlier numbers, if let's say I don't repeat 33 once again, I would be exhausting all those numbers between 0 and 100 at 100 iterations. So the worst case is that I don't hit this number in 100 iterations. So at the last iteration, last random number that I provide to the program might be 1. So I would be guessing the computer's number at 100 iterations. Best case, the computer picks 10, and my random number also picks 10. So I guess the number at 1 iteration. Okay. So all these 3 cases give us the same complexity. If I start picking numbers, so pick any number and keep track of the lower and upper bounds of previous guesses. So you switch your lower and upper bounds. It's again 1 iteration to 100 iteration complexity. Best case 1, worst case 100. But if you start picking the middle number all the time for this range between 1 and 100, the best case is 1 iteration again. The worst case is 8 iterations. So we are in most of the time when we are running algorithms, we are interested in both worst case and average case complexity of those algorithms. You might want to design your algorithm in a way that maybe not in the worst case, but in average case, it should be performing in an optimum path. So there will be several hundreds of thousands of users at the same time trying to access your database, your online application, your social media website, etc. So you would want your algorithms to return their result in a reasonable time with very little resources, with as little resources as possible. But that depends on the importance of your application. You might want to consume memory in favor of consuming less time. So it's all dependent on your problem. You might also want to reduce the amount of memory but increase the CPU cycles. Again, this increases the time that you're going to return, that your algorithm is going to produce a result. So this is depending on how critical your data is. You should be familiar with these worst case analysis, best case analysis. Best case is another important fact, another important metric in your algorithm design. So if you have, let's say, a best case, at best case, if you find your number at 100 iterations, that's not something that you would like to do. So let's say your solution is, let's say your number generator generates numbers between 90 and 100. If you start picking from 1, best case, you're going to have 90 iterations. So this is not a solution that you would prefer. So the best case analysis, worst case analysis, and average case analysis of algorithms is an important metric when you evaluate your application quality. Okay, this spiral can be drawn using a while loop. Before reading this content, just try to solve it on your own, and then you can always look at the solution. Okay, so we have covered the algorithms, data structures such as lists, tuples, some sorting of numbers, dictionaries, and sets. And we have also discussed the while loop in brief, which is very similar to the if check, only that it's going to repeat itself as long as the condition is true instead of executing only once, as in the if case.